Hi everyone, I'm Zoe Lee. I'm a PhD student from the Department of Electrical and Computer Engineering at the University of Virginia. Today I'm going to present a recent work on runtime detection of executional errors in robot-assisted surgery. Despite the developments in automatic techniques for evaluations of surgical skills, there are challenges in ensuring safety in robot-assisted surgeries. Previous works show that the performance of data-driven error detection techniques is affected by the limited availability of labeled training data. In this work, we focus on runtime detection of executional errors, which are defined as a failure of a specific motor task within a procedure. Our pipeline takes into the time series kinematics data and then feed the data into a neural network model to perform runtime error detection. We aim to investigate the following research questions. First, we want to know whether learning the differences between erroneous and normal trajectories using dual input Siamese network provides better deep learning performance than single input network. Second, we investigate into how incorporating the knowledge of tasks and gestures with different training setups affects the performance of erroneous gesture detection. We do this by designing 4 different training setups that combine gesture and task together. From our experiments, we observed that increasing the amount of training data by adding relevant data improves performance more than adding irrelevant data. From the first figure, we can see that the black line representing the performance of model trained with all gesture data is always lower than the green bar, which represents the performance of model trained by combining the same gesture data of 2 tasks together. Our experiments also show that dual input Siamese neural network can achieve on average a better performance than single input CNN and LSTM models at both the gesture and task specific settings. In the second figure, we show the performance comparison between single input networks and dual input Siamese neural networks when they are trained by combining similar gesture data. Our runtime analysis shows that single input CN takes less time than LSTM. This could be due to hundreds of hidden states within the 3 LSTM layers for our LSTM network that each must be computed sequentially. However, for the CNN, outputs from the convolutional layers can be calculated in parallel on the GPU. Our analysis of the inference time for the Siamese neural network shows that the computation time per window was proportional to the average window pairs per unknown window. This is because the Siamese networks pair each unknown window with all the known windows from the training data for voting and process more data at inference. Therefore, for runtime error detection using Siamese CNN networks might be preferred. In conclusion, our results show that using Siamese network and training with similar gesture data could help improve performance when there is only limited data. Future work will focus on evaluating the performance of the end-to-end gesture-specific error detection models by analyzing the trade-off between timeliness and accuracy.